Marginal analysis in business economics, study of rate of change in economic quantities is the marginal analysis. Let's begin with some definitions. The total cost. The total cost function is denoted by C of x. And the marginal cost, marginal means the rate of change, that means you're going to take the derivative. So the marginal cost is the derivative of cost function. So you take the derivative, which is C prime of x, C prime of x. What does it mean? It means the change in cost when one more item is produced or is made. One more item is made. Now the revenue function, the total revenue is denoted by R of x, and the marginal means rate of change, that means the derivative. So the marginal revenue is the derivative of the revenue function, and profit function is denoted by P of x, and the marginal profit is the derivative of the profit function. Now let's look at an example. So in this example, you are given a price demand equation and cost function. So the cost function is given by this C of x equals to 150,000 plus 30x, and the price is lowercase p equals to this, where p is price in dollars. Okay, question number A. How do you find the marginal cost? Marginal cost. So the marginal cost is the derivative of the cost function. So we are given the cost function C of x. This is the cost function. So to get the marginal cost, you simply take the derivative of that function. So C prime of x equals to, so the derivative of 150,000, which is 0 because it's a constant, plus the derivative of 30x, which is 30 times 1, so which is equals to 30. So the marginal cost equals to 30. What does it mean? It means it costs $30 to make a TV at any production level. Okay, then find the revenue function. So you are not given the revenue function, but you are given enough information to find the revenue function. So the revenue function, which is denoted by R of x, revenue equals to total number of items sold times the unit price. So the total number of items is given, which is x number of TVs, and the price for each TV is P. So we can find the revenue function. So total number of items is x times the price, which is 300 minus x over 30. Now we can distribute this. We get 300x minus x square over 30. Okay, now how do we find the marginal revenue? So marginal revenue, which is the derivative of the marginal function R prime of x. So if you take the derivative of the if you take the derivative of this revenue function, so you're gonna get the marginal revenue. So marginal revenue equals to the derivative of 300x is 300 minus, you put 1 over 30, which is constant, you put this aside, then take the derivative of x square. So the derivative of x square is 2x. It's 2x. Now you can simplify this. So it's a 15. So this equals to 300 minus x over 15. So this is the marginal revenue. Now let's evaluate this marginal revenue at x equals to 3000 and x equals to 6000. So when x equals to 3000, the marginal revenue r prime of 3000 equals to, you simply plug x equals to 3 in this equation. Okay, so this equals to 300 minus 3000 divided by 15. If we simplify this, so this is 30 by 15, which is 2, so it's a 200 which is equals to 300 minus 200, which is 100. So marginal revenue at x equals to 3000 is 100. This means the revenue is increasing. Revenue, the rate of change is positive, means it's increasing. So revenue is increasing by $100 per TB. Now when x equals to 6,000, that means when you produce 6,000 TBs, so what is the marginal revenue? So r prime of 6,000 equals to 300 minus, again you plug x equals to 6,000 here, so 6,000 divided by 15. Now if we simplify this, it's a 4 and 400, so this equals to 300 minus 400, which is negative 100. So rate of change is negative. Rate of change is negative means decreasing. That means the revenue is decreasing by $100 per TB, $100 per TB. Okay, now when do you make profit? When x, the cost function, when the cost function c of x is less than r of x, then you make profit. When the cost function, so you make profit here, you make profit. When c of x is greater than r of x, this means what? That means the cost is bigger than the revenue. That means you make loss. How about c of x? C of x equals to r of x. C of x equals to r of x. This means there is no profit, no loss. These points are called break-even point. Break-even point. Okay, now let's look at this thing on a graph. So this is x-axis and this is y-axis, and let's draw the revenue function. Okay, let's draw a revenue function. Let's say this is the revenue function, r of x, and let's say this is the cost function, c of x, the straight line, c of x. Okay, now when the revenue is bigger than c of x, the cost function, that means here you make the profit. But when the revenue is smaller than cost function, then you make the loss. How about these 2 points? When these two curves intersect each other, so these points These points are called break-even points. Break-even points. Break-even points. Here along x-axis it's a cost and the revenue function, and along x-axis it's a number of products or number of TVs. Okay, now let's look at the profit function. How do we find the profit function from the given example? So profit function, you know, the profit function, profit function p of x, profit equals to total revenue minus total cost. So this is the profit. So we derived the profit revenue function in the previous problem, which is 300x minus x square over 30, and minus the cost function is given, which is 150,000 plus 30x. Now let's simplify this. So 300x minus 30x, which is 270x, then minus x square over 30 minus 150,000. Okay, now what is the marginal profit? The marginal profit, marginal profit. So the marginal profit is the derivative of this profit function. So p prime of x, which is equals to, if we take the derivative of this function, so which is equals to 270, the derivative of 270x is 270 minus 130 times the derivative of 2x, x square is 2x, and the derivative of the last term is 0. So again we can simplify this. It's 15, so which is equals to 270 minus x over 15. So this is the marginal profit. Okay, now find the marginal profit at x equals to 1500 and 4500. Okay, now when x equals to 1500, the marginal profit at 1500, p prime of 1500 equals to 270 minus 1500. You plug x equals to 1500 in this equation, and over 15, which is equals to, again we can simplify this. It's 1500 over this, which is 100. So 270 minus 100, which is 170. So the marginal profit at x equals to 1500 is 170. This means profit is increasing because the rate of change is positive. So profit is increasing by $170 per TV. Now when x equals to 4500, what is the marginal profit? 4500. So p prime of 4500, which is equals to 270 minus 4500 divided by 15. Again we can simplify this. So which is 300, which is equals to 270 minus 300, which is negative 30. So this case the rate of change is negative. At x equals to 4500. That means the profit is decreasing. So profit is decreasing by $30 $30 per TV. $30 per TV. Okay, now sometimes it may be desirable to look at the average, to look at the averages. Now let's find the average. So the average cost. So we are given, we know the cost function is denoted by C of X. So the average cost is C of X equals to C bar of X equals to the total cost divided by total number of items. And the marginal, again the marginal means the rate of change. So we simply take the derivative of the C bar to get the marginal average. Then average revenue, so revenue is denoted by R of X. So the average revenue is R bar X. So R bar X equals to total revenue R of X divided by total number of items. Then the marginal average is simply you take the derivative of R bar X. Same thing goes for the profit function. So the average profit, which is P bar of X, which is equals to total profit P of X divided by total number of items. And the marginal average is you simply take the derivative of this P bar of X. Okay, now let's find the average cost of the previous problem. So the average cost, average cost, which is denoted by C bar of X, which is equals to C of X divided by X. So we are given this cost function, which is 150,000 plus 30x divided by total number of item is X. So if we simplify this, you're gonna get 150,000 X inverse plus 30x over X, which is 30. Okay, now what is the average cost when X equals to 1000? At X equals to 1000, the average cost, you simply plug X equals to 1000 in this function, so which is 150,000 divided by X prime, which is 1000 divided by 1000 plus 30, which is equals to, if we simplify this, you're gonna get 150. So 150 plus 30, which is 180. That means the average cost of one TV is $180. Okay, then the next question is the marginal average cost. The marginal average cost. Okay, so the marginal average cost, which is C bar prime. So you take the derivative of C bar. So we have C bar function is this function. So if you take the derivative of this function, then you're gonna get 150,000, and derivative of X prime is -1 times X to the -2, and the derivative of 30, which is 0. So this equals to -150,000 divided by X square. Okay, now when X equals to 1000, what is the marginal average cost? When X equals to 1000, what is the marginal average cost? You simply plug X equals to 1000 in this expression to get the marginal average cost. So excuse me. C bar prime of 1000 equals to negative 150,000 divided by 1000 square. This equals to, if you do the math, then you're gonna get negative 0.15, negative 0.15. This means the average cost is decreasing since the rate of change is negative. So the average cost is decreasing. The average cost is decreasing by $0.15 or 15 cents per TB. Similarly, you can find the average revenue, and just simply divide the revenue function by total number of items, which is X. And to get the marginal average revenue, you simply take the derivative. Same thing goes for the profit. The average profit is profit divided by profit function by X. You take the derivative. And for a particular point, let's say X equals to A, so you plug X equals to A to get the marginal average profit at that point. That's all from this section. I'll see you in the next class. Thank you.